I'm going to show you the different ways we mapped out the moon to land our robotic landers and the Apollo astronauts on it. I'm John Williams, and I am at the Space Imagery Center in the Lunar Planetary Laboratory in the University of Arizona. And I'm here with Dr. Byrne, who's the director of the place. So Dr. Byrne, what are you going to be showing us today?
Well, welcome to the Space Imagery Center.
Thank you.
I thought I'd start by showing you some of our historical activities, and then we'll segue into what we're doing today on Mars and on the Moon.
Awesome. So where do we want to start?
All right, let's start over here. And the Space Imagery Center has been around since the 1970s. The Lunar and Planetary Lab has been around even longer than that, since the 1960s. We were founded by Gerald Kuiper, who is one of the founders of the whole planetary science field in general. So originally we spent a lot of time mapping the moon because of the run-up to the Apollo program. That was what was of greatest interest, and the Air Force commissioned several lunar atlases that Dr. Kuiper and his colleagues at the time put together. Just to give you an idea of how that was done, I can demo some of what we have set up here. We took telescopic data and put it together into atlases, but as you might imagine, like at the edges of the moon, things are very foreshortened and difficult to see. So some of these telescopic data were reprocessed in a way that is easy to do with modern day computers, but was quite difficult at the time, and it was done in a very analog fashion. So to try and see what was at the edges of the moon, we would reproject these images onto a globe. So I'll just give you a demonstration here of just roughly how this works. We have a globe here that Dr. Kuiper and his colleagues used. They would take glass plates from the telescope where these images were recorded, reproject them back onto this sphere, and then rephotograph the sphere from right overhead. So there's a couple of features of interest marked here. So there's outlined in the red here, there's Mare Crisium, so that's one of the lava fields on the lunar surface. There's also right down there at the very bottom at the edge, there's another red area outlined, and that's the Oriental Impact Basin. Now the Oriental Basin is very hard to identify as an impact basin in this perspective, but if you re-photograph it from directly overhead, you can start to see that it's this giant circular feature about 900 kilometers across. So a truly enormous impact basin that if you look at it from directly overhead looks something like that, about 900 kilometers from rim to rim here, but if you are looking at it from like right at the edge of the moon, is really difficult to see at all. So what Dr. Kuiper and his colleagues did was put together a atlas of these rectified images. So this is an example here of the Oriental Basin. So after rephotographing these from directly overhead, you can start to see the edges of this double rim impact basin right here.
And of course you mean by foreshortened, these get blurry as you project the images.
Yeah. So the resolution of the images goes down as you get to the edge, because every resolution element, or pixel if you like, in the camera, although it wasn't electronic back then, is stretched over a larger and larger area of the moon's surface, until eventually when you're right at the edge, then it's stretched over something that's almost infinitely big.
Absolutely.
So this was the earliest attempts to map the moon and to put together just an atlas that would help guide future exploration. After that, spacecraft became more common, and the Lunar Planetary Lab played another integral role in that. We were involved in the Ranger missions, the Surveyor missions, the Lunar Orbiter missions. In fact, with the Surveyor landers, we both at the time identified the landing site because that was not known. So we had to reconstruct that from images of the moon and figure out exactly where the lander was. But also today we're leading an effort to digitize the images of the landing site of the Surveyor lander, which aren't available online at the moment, but you can make mosaics of some of the Surveyor landing sites, like what you see here. So some of these areas were never visited by the Apollo astronauts because they're in the lunar highlands, and that's too rough and risky to attempt a human landing there. But so there's still some scientific utility to these data.
This really helped us get to the moon and understand it.
It did, yeah. And the science payback from all of those missions and the Apollo program that came right after it still continues to this day. Even the samples from Apollo are continually being analyzed, and we've got facilities in the basement here that are working on those samples right now and doing analysis of those lunar rocks. There are some other images taken of the lunar surface from the Apollo command modules and those lunar orbiters. I can show you a couple of examples. So, for example, I can just pull out a few here.
Awesome.
So these are cameras that were mounted to the lunar orbiter. I mean, sorry, the Apollo command modules, and they were able to build up coverage over a substantial fraction of the lunar surface. The lunar orbiters that got global coverage, and Apollo did pretty well over the equatorial areas. But these data are available online now, but we still keep these original prints here for historical reasons and and aesthetic.
Awesome. So yeah, and you have most of these prints from every Apollo mission.
We do, yeah. And the Lunar and Planetary Laboratory has been involved in just about every NASA mission that's happened from that era onwards. So all the way from the original telescopic mapping of the moon and that process of like orthorectifying the images all the way up to the current day. And some of our current projects include the HiRISE telescope, which is at Mars at the moment on Mars Reconnaissance Orbiter.
Yes.
We operate that telescope here at the University of Arizona.
That's amazing.
Yeah, we compile all the targets, make the observation plan, and ship that off to NASA, who communicates it to the spacecraft. So we also process all the data here as well from that mission.
Wow.
So yeah, we're fortunate to have a lot of spacecraft operations mixed with an academic environment that can benefit students and also the researchers that are here. So we've got a long tradition of mixing spacecraft operations and research here.
I see. That's awesome. And even with the modern day, this is the old way we did it, but now we're using the Lunar Reconnaissance Orbiter.
Yeah.
And yeah, we're continuing to map out the moon.
Yep, we have a lot of modern day analysis going on. So we'll see some later. We'll see some examples of how we do this kind of reprojection of images in a more 21st century fashion. Yeah.
Well, thank you, Dr. Byrne.
Yeah,
it's awesome. Thank you so much for watching. Click the subscribe button and check out my other videos. Have a great day.
Our mission is to make you space intelligent.